Imagine a scene from nearly 70 million years ago. A large meat-eating dinosaur has just caught its prey. It is a powerful hunter, with long legs and sharp claws. This dinosaur, a type of Megaraptor, has a small crocodile trapped in its powerful jaws. This was likely its last meal. This incredible moment from the deep past was frozen in time. Scientists in Argentina recently uncovered the fossil of this very dinosaur. They named it Joaquinraptor casali. Its discovery gives us a rare and exciting window into the life and death of one of the last dinosaurs to walk the earth. It's a story of a predator and its final, fateful hunt. This discovery is more than just another dinosaur skeleton. It is a snapshot of an ancient behavior, something fossils rarely preserve for us to see. Finding a dinosaur with its food still in its mouth is incredibly unusual. It's like finding a photograph of a moment that happened millions of years before cameras even existed. The scientists who found Joaquinraptor were amazed. They didn't just find bones, they found a story captured in stone. This single fossil helps us understand what dinosaurs ate and how they interacted with other animals in their environment. It's a direct piece of evidence, not just a guess based on tooth shape or body size. The dinosaur's last moments must have been sudden and dramatic. After catching the crocodile, something happened that caused the Joaquinraptor to die. Perhaps it was injured during the hunt, or maybe a sudden event like a flood or a landslide buried it quickly. Whatever the cause, its death was so swift that it didn't even have time to finish its meal. The small bones of the crocodile were preserved right where they were when the dinosaur died, inside its mouth. This preservation is what makes the fossil so special. It tells us not just what Joaquinraptor ate, but also provides clues about the very last moments of its existence on our planet. For paleontologists, this is a dream discovery. They spend their careers looking for clues to build a picture of the prehistoric world. Usually, they have to piece together information from scattered bones and fossilized footprints. A discovery like Joaquinraptor offers a much clearer view. It connects a predator directly to its prey. This helps confirm theories about what megaraptors hunted and how they used their specialized bodies to catch food. It's a tangible link to a world that vanished long ago, bringing a fearsome Cretaceous hunter back to life in our imaginations, complete with its final croc-filled bite. Joaquinraptor casali belongs to a group of dinosaurs called Megaraptors, which translates to giant thieves. These were some of the most formidable predators of their time. Megaraptors were large, two-legged carnivores, known for their unusually long arms and enormous, sickle-shaped claws on their hands. Unlike Tyrannosaurus rex, which had tiny arms, Megaraptors used their powerful forelimbs as their primary weapons for hunting. They lived during the late Cretaceous period, the final chapter in the age of dinosaurs. This was a time when the continents were moving into the positions we know today, and the world was filled with a diverse array of giant creatures. The fossil of Joaquinraptor was discovered in a region of Argentina known as Patagonia. This area is famous among dinosaur hunters for its incredible fossil riches. Over the years, paleontologists have unearthed some of the largest dinosaurs ever known from Patagonian soil, including the colossal plant-eater Patagotitan and the fearsome meat-eater Giganotosaurus. The rocks where Joaquinraptor was found date back to about 70 million years ago. This places it right at the end of the Cretaceous, not long before the massive asteroid impact that would wipe out the dinosaurs for good. It was one of the last of its kind. Living in late Cretaceous Patagonia meant Joaquinraptor shared its world with a host of other amazing animals. The environment was likely a mix of forests and floodplains, crisscrossed by rivers teeming with life. Other fossils found alongside Joaquinraptor help us paint a picture of this lost ecosystem. There were other types of dinosaurs, both large and small. There were also turtles, fish, and, of course, the very crocodiles that became a meal for our hungry Megaraptor. This predator was not the only hunter around, but its size and powerful claws would have made it a dominant force in its habitat. Scientists estimate that Joaquinraptor casali was a medium-sized megaraptor, measuring around 16 to 20 feet long. While not the biggest predator in its environment, it would have been a fast and agile hunter. Its long legs were built for speed, allowing it to chase down prey across the ancient plains. Its specialized hands, armed with those terrifying claws, were perfect for grabbing and slicing. The discovery of Joaquinraptor adds another important member to the Megaraptor family tree and helps us understand how diverse these predators were just before their final extinction. The fossil of Joaquinraptor casali is a treasure trove of scientific information. The skeleton itself, though not entirely complete, provides many essential clues about the animal's life. Paleontologists carefully examined every bone, from its skull to its legs. They noted the shape of its teeth, which were sharp and curved, perfectly designed for slicing through flesh. The bones of its arms and hands confirmed its identity as a megaraptor, showing the characteristic long limbs and attachments for powerful muscles. These features tell us that Joaquinraptor was an active predator that relied on its arms and claws to subdue its prey. A different hunting style from dinosaurs that relied only on a powerful bite. The most exciting clue, however, was found nestled within the dinosaur's jawbones. There, scientists identified the delicate bones of a small prehistoric crocodile. This wasn't just a random bone found nearby. It was clearly positioned inside the mouth of the predator. This is what scientists call a gut content, or, in this case, mouth content fossil. Such direct evidence of a predator-prey interaction is extraordinarily rare in the fossil record. It provides undeniable proof that Joaquinraptor hunted and ate crocodiles, something that could previously only be inferred from the ecosystem it lived in. This single bone changes speculation into fact. Analyzing the crocodile bone itself gave scientists even more information. By studying its size and features, they could identify the type of crocodile it was and estimate its size. This tells us about the specific prey that Joaquinraptor targeted. It seems this dinosaur wasn't just going after other dinosaurs. It was also hunting smaller animals that lived in and around the rivers of its environment. This suggests that megaraptors were adaptable hunters, capable of catching a variety of different animals. It paints a picture of a versatile predator that played a key role in its ecosystem's food web, helping to control the populations of smaller creatures. Beyond the crocodile bone, the way the dinosaur's skeleton was preserved offered other clues. The bones were found articulated, meaning they were still connected in their natural positions. This suggests that the animal was buried very quickly after it died, before its body could be scattered by scavengers or the elements. Rapid burial is key to creating such a detailed and informative fossil. It protected the delicate crocodile bone and kept the dinosaur's skeleton intact, preserving this incredible prehistoric moment for millions of years, until it could finally be uncovered by the curious eyes of modern science. Discoveries like Joaquinraptor casali are vitally important because they provide a direct look into the behavior of ancient animals. For a long time, our understanding of what dinosaurs ate was based on indirect evidence. Scientists would look at the shape of a dinosaur's teeth, sharp for meat, flat for plants, or study fossilized droppings known as coprolites. They might even find bite marks on the bones of other fossils. But finding a predator with its last meal still in its mouth is the ultimate confirmation. It's like catching the animal in the act, providing a solid piece of evidence that helps us move from guessing to knowing. This fossil is a rare gift because the conditions for its creation were so specific and unlikely. For us to find a dinosaur with its prey, the predator had to die suddenly right after catching its meal. Then, its body had to be buried rapidly in sediment, like mud or sand, which protected it from being eaten by scavengers or decaying away. Over millions of years, this sediment had to turn to rock, preserving the bones. Finally, those rocks had to be exposed by erosion in a place where paleontologists could find them. The chances of all these things happening are incredibly slim, which is why fossils that show behavior are so precious. Every new fossil discovery, especially one as detailed as Joaquinraptor, helps us refine our understanding of the prehistoric world. It adds a new piece to the giant, complex puzzle of life on Earth. This single specimen tells us about the diet, hunting strategy, and environment of a specific group of dinosaurs. It confirms that megaraptors were skilled hunters of smaller, agile prey, not just scavengers or hunters of large dinosaurs. It also enhances our picture of the ecosystem in Patagonia 70 million years ago, showing us the intricate relationships between the different animals that lived there. It's a story of survival and competition written in stone. Ultimately, the tale of Joaquinraptor and its final crocodile meal reminds us that the world of dinosaurs was just as complex and dynamic as our world today. These were not just monsters from a forgotten time. They were living, breathing animals with behaviors and relationships that shaped their environment. Each new fossil helps us bridge the vast gap of time and connect with these incredible creatures. By studying these ancient mysteries, we learn not only about the history of dinosaurs, but also about the long, slow, and often surprising story of life itself on our planet.